Hello and welcome back to Everything Boats with Captain Franklin here, where we discuss boats and boating, from maintenance and repairs to seamanship and safety, as well as everything in between. This podcast is a companion to my YouTube channel of the same name, so if you like and find it useful, be sure to subscribe and please check out my YouTube channel as well, where you'll find hundreds of informative videos on pretty much every boating topic imaginable. Today's podcast, Inspecting Your Boat's Electrical Systems, Part 4, Onboard Charging Systems. Hello and welcome to another episode of Talking Naughty with Captain Frank. Today we're wrapping up my four-part series on how to inspect your boat's electrical systems for issues. The goal, of course, of all these four episodes is to head off potential problems while keeping your hours on the water hopefully both safer and electrically trouble-free. In my last video, we talked about inspecting your AC and DC system circuit breakers and wiring. If you missed that, I'll include the link to that article in the description section below. I'll also post links to the previous two articles on inspecting your DC and AC power systems. Today's topic is how to inspect your onboard charging systems. And by that, I mean battery chargers, charger inverter units, as well as solar and wind power systems. Before we get this party started, a reminder, if you enjoy this video, please like, subscribe, and share with all your friends and all the people you hate too. Safety first. Although the inspections and checks mentioned in this series are geared towards the average boater, always seek the advice of a competent marine electrician, preferably one familiar with the standards and recommendations provided by National Fire Prevention Association, NFPA, and the American Boat and Yacht Council, ABYC. So you want to consult an electrician if you have any questions or doubts about these inspections, or if you find problems during your installation that you don't feel like you're able to tackle to correct. So let's get right into battery chargers and inverter charger units. Marine grade batteries aren't cheap and can easily be destroyed by improper charging. Meaning the last place you want to skip is when selecting your inverter charger or battery charger unit. Go with a good quality marine grade unit, ideally one built to ABYC and UL standards. Look for smart chargers that provide numerous charging options and features, such as the ability to select between the different battery types, such as wet cell, gel, and AGM or absorbed glass mat. Stay away from those El Cheapo automotive battery type chargers that you'll find down at the local S-Mart. They're not designed for marine use and can cause a multitude of problems, from stray current corrosion to shock hazards. Always consult the manufacturer's instructions when sizing your charger. General rule of thumb is to choose one with an output that's at least 10% of your battery or battery bank capacity. In other words, if you have a 300 amp hour battery or bank, then you'd want a 30 amp charger, 10%. If you can't find an exact match based on the above, a charger with a little more output is better than one that's too wimpy. So, go with the large one rather than the small one. Start by inspecting the battery charger for corrosion, physical damage, moving parts, charred or loose connections, and other such issues. Your charger should be installed in a cool, dry area with plenty of ventilation. A higher location is generally better than a lower one, as it typically provides better ventilation and protection from the corrosive humidity of the bilge. Chargers should be installed as close as possible to the battery or battery bank, as close as practical, but not mounted directly over the batteries, because batteries can produce corrosive gases while charging, which can quickly damage a charger located above them. So let's talk a little bit about inverter battery charger units. First off, what is an inverter? What does an inverter do? So essentially, an inverter converts your boat's DC battery power to AC electricity. Larger permanently mounted inverters will typically have a battery charger built in, precluding the need for a separate battery charger. Start by inspecting the inverter for corrosion, physical damage, missing parts, charred or loose connections, and other such issues. Make sure your installation follows all of the manufacturer's instructions and recommendations. Your charger should be installed in a cool, dry area, again with plenty of ventilation. In general, inverters should be installed within 10 foot of your batteries, if possible, or battery bank, to avoid voltage drop or the need for oversized wires to overcome this. ABYC installation recommendations includes the means of securing DC power to the inverter in the event of an emergency. The easiest and simplest way to do this is to just install a standard dedicated battery switch for it, right? The simple on-off switch. What you want to do is you want to be able to kill DC power to the inverter in case that thing starts smoking or whatever. They also require that the case ground of an inverter be connected to the engine negative terminal or DC negative bus bar with a ground wire. And the problem I typically see is that this ground wire, if it's present, is not big enough. It has to be of equal ampacity to the DC positive conductor supply and power to the inverter. So in other words, the ground wire for your inverter charger case has to be of the same size as the conductor that's providing positive power from the battery to the inverter charger unit. They have to be the same size. That way, if it shorts out, it can shunt all of the power coming into ground. Less than half the inverter charger installations I see during the marine surveys have the required cutoff switch, while maybe 1 in 50 will have a properly sized case grounding wire, with many of them having none. Inverters that integrate into your existing AC system come with additional requirements. These include a visible means of determining that the AC inverter is online, such as a gauge or a control panel. You also have to have a warning sign at the main AC panel stating that the system includes an inverter. This is important to warn and prevent shocks to technicians working on the AC system. In other words, if someone's going to be working on your AC system on your boat, this sticker at the panel says, hey, you know what, we've got an inverter on board. So just because you unplug the shore power from the dock pedestal, that doesn't mean that you don't have AC power present. So let's talk a moment about ignition protection. Only battery chargers labeled as being ignition protected can be installed in a gasoline-powered vessel's engine compartment due to the risk of explosion. Inverters are not ignition protected, none that I'm aware of anyway. So an inverter charger unit should never be installed within the gasoline engine compartment or in general spaces containing fuel. So read your inverter instructions carefully when you are choosing a location or you're inspecting your existing installation. So now let's talk a little bit about solar panels and wind turbines. Many sailboats will typically have a couple of solar panels and a wind turbine or possibly both. Here's what to look for when you're inspecting those that are installed on your boat. Solar panels have a lot going for them. They're noiseless, they have no moving parts, and they provide free electricity for years with minimal maintenance. They're also modular, allowing you to start small and add more as your power requirements increase. Solar panel system inspections are pretty straightforward. First off, check the panels for physical damage while ensuring they're securely mounted. From a functionality inspection standpoint, fixed panels will typically perform best when mounted in a horizontal or flat position. Articulating panels, which allow you to aim the panel towards the sun, thus generating more power, are a good option. You can maximize their output. In other words, if you can adjust the surface of the panel so that it's continually tracking the sun, you get more power out of it. Unfortunately, with that comes the requirement to move the panels throughout the day as the sun, transits from the sky. So if you want the maximum benefit of an articulating panel, then you're going to have to move it a couple, 3 or 4 times throughout the day. Inspect wire runs for issues such as chafe, lack of support, or improper connections. And you also want to ensure all your wire run deck penetrations are properly sealed and watertight. This is to prevent water migration into panels with coring. In other words, if you've got a wire that transitions to a cored deck, then you want to make sure you properly seal that coring and make sure that water doesn't enter into the deck, the coring of the deck, and start to cause problems such as delamination and rot. I will be doing up a article on how to properly make wire penetrations and mount stuff into a cored deck. So watch for that in a future video. One of the most common issues I find with solar panel installations is lack of a charge controller or regulator. This is a must-have piece of equipment for any solar panel installation to prevent overcharging of your batteries, as well as to ensure they're charged to their full potential. The charge controller should be mounted below decks and as close to the battery or battery bank as possible. Next up, let's talk about wind turbines. Unlike solar panels, which require sunlight to operate, wind turbines have the potential to generate electricity 24 hours a day, 365 days a year. Start your inspection of your wind turbine from a safety aspect. Turbines should be mounted in a location that's easy to access for maintenance or to tie it off as required for storm preparations, yet high enough to prevent accidental contact with crew member heads and other body parts. Verify that the turbine is securely mounted on a suitably strong structure, such as a stern pole or an arc. Stern poles will consist of a stainless steel or aluminum tube about 2 inches in diameter. As far as the material itself, they both have their pros and cons. Stainless steel is stronger, while aluminum tubing is lighter and easier to work with. It also has a little more flexibility
which kind of tends to dampen the vibrations. And if you've ever had to sleep in a bunk beneath a wind turbine or near it, you'll know what I'm talking about. Regardless of material, a stern pole must be firmly mounted with rail clamps, guy wires, and or rigid metal struts to provide diagonal support from the deck to the pipe. Bracing is crucial for strength and to reduce pole movement, which again in turn minimizes vibration and noise below decks. As with solar panels, your wind turbine must also have some form of power regulation to prevent overcharging of its batteries. Some turbines have a built-in regulator, which, similar to the solar panel charge controllers, reduces output by throttling power production once your battery bank is fully charged. Other turbines, particularly higher quality units, will feature an external charge controller unit and a diversion resistor, or also known as a dump load resistor. This design doesn't stop wind turbine output, but rather diverts excess power to one or more dump load resistors once the charge voltage cutoff set point is reached, where it is then dissipated in the form of heat. In other words, you set what you want the output or the charge voltage max to be. The wind turbine pumps that out, and then when it reaches that, your batteries reach that maximum cutoff point or voltage set point that you've entered, then the excess power, the generator doesn't stop producing power. It just diverts it to the dump load resistors. If your system features a dump load resistor, verify that the resistor, which can get extremely hot during use, is properly installed to prevent a fire. The system should also have proper fuse or break protection, ideally a stop switch, which allows you to shut down the wind turbine in the event of a storm or to prevent starting of the rotor during maintenance, repairs, or when working in the wind turbine area. Finally, you'll also want to confirm that the wire run deck penetrations are properly sealed and watertight, just like any other deck penetrations we've talked about previously. Inspect the installation and verify that the connections are corrosion-free and that the wire runs are properly supported and free from chafe or other issues. Many of your boats, particularly sailboats, will have a hybrid system, a combination of solar and wind power. This type of installation gives you the best of both worlds, because if you think about it, many sunny days you don't have a lot of wind, and if it's cloudy, you have a lot of wind. So that, enables the solar panels to take the load during the sunny, windless days and the wind turbine to take it during the cloudy, windy days. If you have a solar and wind power system, a hybrid system on your boat, you have to take into consideration what's called charge controller confliction. Charge controller confliction is an issue where the charge controller for your solar panel and the charge controller for your wind turbine are internally adjusted to the same maximum charge voltage set point. In other words, you think, okay, I need to have X amount, 14.7 or whatever for my max charge voltage. I'm going to set the solar and the wind. Well, what happens is the result of doing that, both charge controllers are constantly fighting each other, turning each other on and off while jockeying for position as a dominant charge source, meaning that the battery or battery bank won't be fully charged. Charge controller confliction is easily resolved. Adjust the cutoff voltage of the charge controllers for the solar panel and wind turbine. Incoming. Just wait till this plane goes through. That's another key. That's another key indicator of where we're at. Charge controller confliction is easily resolved. Adjust the cutoff voltage of the charge controllers for the solar panel and the wind turbine so that one is the dominant charging source. In other words, you're going to pick one. If you have, if solar is where you're getting most of your power, then you make that system the dominant charger. If wind is where you're getting the most of your electricity generated, then you make that the dominant source. So all you do is, you've got your cutoff voltage. You set the dominant power source to the maximum cutoff voltage, and then you reduce the subordinate one to about 0.2 volts less. That eliminates the potential for them to have this charge controller confliction. They're not going to be fighting, right? You're going to get to 0.2 volts below your maximum battery charge, and one of them's the subordinate one's going to cut off, and then the dominant one's going to take the battery charge or battery bank charge up to that maximum cutoff point.